Thanks to Cisco for sponsoring our day of podcasting at KubeCon. We had some great conversations. Thanks again to Cisco. You can learn more about Cisco and their microservices platform at mantle.io. That's MANTL.io. Hey, it's Alex Williams, the New Stack here at KubeCon in Seattle. It is day 2, and we are here with Mathew Lodge of Weaveworks. Hey, Mathew.
Hey, Alex. Good to see you.
Good to see you, and joined by our colleague in podcasting, Lee Calcote of SolarWinds. Hey, Lee.
Hey, Mathew. Hey, Alex.
So, Lee wrote one of our chapters in our ebook on monitoring. You wrote about Prometheus along. Was it in one of the ebooks, or where was it again?
Yeah, that's a good. On it ended up being a tutorial.
Right.
About how to contribute to sort of what is Prometheus and kind of how to crack open some of that code and contribute to it if you wanted to.
Right.
And it looks like some people are doing just that.
Yes, that's right. That's exactly what we're doing.
So you guys are really embracing Prometheus. Maybe you can tell us about what Prometheus is, just basically for folks, and what it is that you're doing, because I understand it's like kind of a horizontal scaling platform.
That's right. That's what we're doing. Yes, that's what we call Cortex. So Prometheus. Let's start there. So engineers at SoundCloud developed Prometheus. So they were ex-Google guys, and they were looking for a monitoring solution that was really going to work for containers and a much more dynamic environment than sort of traditional open source monitoring tools, very much focused on monitoring servers or virtual machines, but they didn't map very well to highly dynamic containerized environments. So, for example, a lot of monitoring tools couldn't keep track of where a container was. This container gets dynamically scheduled, and the monitoring tool just tells you about a particular host, and then you have to go and find the container. So the first thing you have to play, the game you have to play, is find the container. And because they come from Google, inside of Google they have this thing called Borgmon, or used to have this thing called Borgmon, and so they were, they wanted something that was more like that, and so that's how Prometheus got started. So Fabian and Julius were the main engineers over at SoundCloud. And so we've been working very closely with Julius, who's an independent contractor. So Fabian joined CoreOS, and then Julius has been working very closely with us on Cortex. So when they built Prometheus, it's a single host solution, right? So the idea is it goes out and it pulls all the metrics and pulls them into its time series database. It's a multi-dimensional database, and that makes a crucial difference for running queries and troubleshooting. Very different, again, to other open source monitoring tools where it's two-dimensional. You have a time series, you have a value and a timestamp, a value and a timestamp. The problem then comes when you want to correlate all these things together, and you say, great, well, I want to know what are the names of all the containers between 8 and 9 o'clock this morning that had CPU greater than 10% and less than a gig of free memory. Now, in a traditional monitoring system, you have to go and traverse all of those time series, right, and then try and join all that stuff back together in order to execute that query. And so for a lot of them, you just can't run that query. It's not possible. But the nice thing about Prometheus is that all of those data things are stored together at the same time, right? So it's more like a data cube on the back end, so you can run these very complex queries, and you can answer that question, that query I just gave you. You could do that with Prometheus. The drawback of Prometheus is that everything's stored locally on disk, right? So it just writes to the file system, so all your stuff is sitting on the file system. So it has the advantage of being very simple, but at the same time, if you're going to run this for a long period and you've got lots of data, you now have to worry about data management of that data on a local system. So you have to make it durable, you've got to back it up, you've got to be able to restore it in the case that you lose it, and that's what we sought to solve with Cortex. How do we make something that would be a horizontally scalable version of Prometheus? So that's what Cortex is. So you can add instances of Cortex and the data, and it will spread out the load, it will spread out the queries, the data collection, and basically turns it into a horizontally scalable solution.
Horizontally scalable and multi-tenant.
And multi-tenant, yes.
Oh, yeah, very good.
Yeah.
Well, as I understand so part of the way in which you guys are helping solve that long-term persistence of the samples that have been, the data that's been pulled, those time series metrics, is in AWS on
right.
S3.
Yes.
But, not that that's the only long-term storage target available.
Yes.
So I understand maybe Cassandra might be a good fit for that as well. Maybe operationally a little more challenging to.
Yeah, essentially there's an unstructured and there's a structured part of the data set, and we store those in different kinds of data stores. So some of the data can just go straight into S3, as you say, or any object store. It doesn't have to be S3. But we built our implementation on AWS, and so AWS S3 is what we did first.
Yeah.
Right?
Hence, n number of nines or what have you for that.
But we also store some of the more structured information in Dynamo, so to be able to optimize queries.
I understand. Maybe speaking to Dynamo a little bit, and just maybe some of the challenges that you guys have faced as you've gone to bring forward Cortex and begin to make it generally available. Has Dynamo been one of those challenges in terms of scaling it up, or?
Well, Dynamo makes it a lot easier. I mean, it's a schemaless database, and you can with tunable consistency, and so it's actually a really nice service to use on the back end. So we've been very happy with Dynamo.
Okay, very good.
Yep.
So, how do you query? This environment.
Yeah. So one of the other nice things about Prometheus that Julius and Fabian were used to being able to essentially do SQL-like queries in order to do troubleshooting. So if you're trying to track down a metric or find out what's happening, troubleshoot a problem. So there's a whole query language, Prometheus query language, that comes part and parcel of that. So you can interrogate that data cube on the back end in the storage. And so what we did for Cortex was essentially make that so you could parallelize and scale out those queries as well. So those queries would still execute quickly, even though the data is now spread out across multiple instances.
So that sharding, how does that work for you guys or within Cortex?
So in Cortex, essentially it's random. So we store the chunks, we spread the chunks out randomly across the instances, and so they're routed to a random instance. And what that does is the randomness is important because that helps you parallelize queries. We haven't done a lot of query optimization in the current version. So it's pretty simple right now. But that's certainly an area that we can take a look at, or indeed anyone else can take a look at if they want to optimize.
Oh, nice. Okay.
Yeah.
Alex, I'd had the pleasure of being able to spend some time with some of the other maintainers of Prometheus. So Bjorn, I think, who's still at SoundCloud, and Brian Bazil, who's independent and kind of doing robust perception at this point.
Right.
But I mentioned those guys in part because part of my conversation there is coming to understand the genesis of Prometheus as you described, kind of, and part of that PromQL, that query language that Alex is asking about, being inspired from Borgmon. And as I understand it, those that might be familiar with Borgmon and the query language there would just feel right at home within PromQL.
That's right.
But interesting capability in that is, you called it out before, is the multi-dimensional data model. These n number of tags that you can apply to. Right. Have you guys seen customers or that really drawing them in that particular capability, or for maybe specific use cases that they have, or?
Yeah, it depends on their level of sophistication. If you've been doing this for a while, then it clicks very quickly as to why this would be useful, right? Because you know what the limitations are of time series storage and time series databases, right? So having the multi-dimensional, but if you're not familiar with it, it'd be like multi-dimensional. What is that? So
Sure.
It depends how familiar you are with the problem set.
Okay.
But for those who are accustomed to it, what are they using it for?
Well, it's in a dynamic environment, it's really useful to be able to correlate all those things together, because you do want to know, for example, which host your container is running on, and you want to know things about that host, like you might want to know memory pressure or CPU, and because if the container is not working properly, it could be because the host is overloaded. So being able to move up and down the levels of granularity is one of the advantages of that multi-dimensional query model. Right, so you can go take a look at the host, or you can look at the individual container, and you can correlate between those two sets of statistics.
Really being able to slice up your views in many different ways.
Right.
Well, so it just strikes me that Prometheus, it wasn't that long ago that was adopted into the CNCF.
Yeah.
Alexis Richardson is Weave itself is just very much so helping within that environment and stewarding things. And
yes.
There was another announcement just yesterday here at CloudNativeCon about FluentD being adopted into. Are we to be expecting sort of a FluentD-as-a-Service, coming forth, or can we talk about that yet, or
maybe. I'm gonna reserve the right to talk about that more in the future. I mean, we're users of FluentD ourselves at Weaveworks.
So I guess maybe that's more of an interesting question. Is does that perspective from you on whether or not that benefits your use of FluentD as it gets adopted?
That's right. Yeah, I mean, we want to be able to practice what we preach in the CNCF. And so as part of the TOC, and as you said, Alexis is, that CEO of Weaveworks, is the chair of the TOC. We want to build this and incubate in the CNCF a tool set. We're not trying to pick winners, but we're trying to incubate a tool set of tools that you can use to build these new cloud-native applications. And so one of the beliefs of the CNCF is by incubating these projects, you're making it easier people to understand the patterns and find software that helps them do that. The other thing about how we think about this and how the TOC thinks about this is we're not saying there is a single stack that is the answer and you should use Kubernetes and you should use FluentD and Prometheus and that's it. So I expect that we'll have overlapping projects in some areas.
It's a reference architecture.
Yeah, it's more like a reference architecture, but if you don't want to use Prometheus, fine. You can use something else. We're not telling you to do that. Or there might be two things that do the same thing inside of potentially inside of the CNCF. They might have overlap.
So tell us how Weaveworks will offer Cortex then.
So we're offering a service called WeaveCloud. It's currently in beta. And so essentially Cortex is the technology that underpins, one of the technologies that underpins that service.
Okay.
Now, you can use it like a hosted Prometheus service if you want. So if you're already familiar with Prometheus, and you're using it and you don't want to manage it yourself, you want somebody else to run it, you can absolutely use it that way in Weavecloud. But we want to do a lot more with that capability. Essentially, it is giving us a really great way to capture all these metrics directly off the infrastructure, directly at the applications, do that in a very automated fashion, very scalable fashion, and then we can integrate that with other fun things in WeaveCloud.
How does that then change your overall focus at Weaveworks overall?
Well, yeah, we started out with networking, and what we heard from customers around networking is this is really great. We often get customers we never knew were using Weave, and they're already in production with their application, and they say it's working great, but we might need support at some point. So can we talk to you about giving you some money to help us support our production application? It's it's really great to hear those stories because they've been able to get to production without having to ask for help. Right?
Yeah.
And so
but then again, they're getting in production, not asking for help.
But then, what kind of help do they want? Well, they want to be able to troubleshoot problems should they occur, right? They want to be able to understand the health of their Weave network. They want to be able to understand the health of the network overall. They need to be answered the question: is it the network? Right? Right? Something's not working. Is it the network? And so
it must be the network.
It's right. That's right. I was talking to some customers in New York last week, and they laughed when I said that to them because they were like, "Yeah, that happens all the time. That happens every day." Yeah. Right.
If you're a network engineer, you're just used to being the scapegoat.
That's right. So the network engineer is like, "It's never the network," and the software guys are going, "Yes, it is." So Weaveworks is
guilty until proven innocent.
Exactly. So Weaveworks is a really great way of, first of all, visualizing, seeing what's happening. Because you see a live view of your application or its communications and being able to manage that. But then when you start to do that, and then you realize that this monitoring and these capabilities, some of which are powered by Cortex, these capabilities can help you understand your application more and go beyond just the networking use case into understanding the behavior of my application and making it easier for me to understand what's going on and easier for me to find problems when they occur. And so that's the direction we're heading in.
Makes sense. The application just continues to be be the king, kind of take
Yes.
be the most important here.
So is this now the direction that you're going to take with Weaveworks as a company then?
That's right. Yes.
Great. Okay.
Yeah.
Great. Well, good. Well, Matthew, thank you very much for taking some time to talk with us and learning a little bit more about Cortex and and the direction that you guys are taking with Weaveworks, and we're always interested in following you guys and what you're doing. So thanks for just stopping by.
Great. Well, thank you for the time today. I really appreciate the opportunity. Thanks.
Good to talk, Matthew. Thanks, Alex.
Thanks to Cisco for sponsoring our day of podcasting at KubeCon. We had some great conversations. Thanks again to Cisco. You can learn more about Cisco and their microservices platform at mantle.io. That's MANTL.io.